Welcome to TechnorazziLIVE, the show that lets you ask questions of metrology experts. I'm your host, Dirk Dusharme. Well, today we're at the Anaheim Convention Center in Anaheim, California for the MD&M West show. Right now I'm at the Carl Zeiss Industrial Technology booth, where we're going to be introduced to a couple of new Carl Zeiss Industrial Technology products. The first one will be the MICURA CMM, and the next one will be the Surfcom Flex. And with me right now to introduce the first product is going to be Terry Rosine. Terry is an applications engineer for Carl Zeiss Industrial Technology. Thank you, Terry, for having us at your booth.
Thank you, Dirk.
And before we get started, let me remind you that if any time during the show you have questions, just send them, email them to techno-live@qualitydigest.com, and we will be sure to get them on the air. That's techno-live@qualitydigest.com. You should see a link to that underneath your player. So Terry, this is the MICURA CMM, and this is a fairly new product from Carl Zeiss, is that right?
Yes, introduced in October.
Okay, and tell us a little bit about it. How did the product come about?
The product came about through customer requests for a small footprint, high accuracy, low probing force CMM.
And by customer, what kind of customer in particular?
Primarily the medical industry. The same people that are at the show asked for that type of a machine.
Okay, so they were looking for a show that's kind of has the characteristics of this product, which I understand one of the main ones is basically its size, right?
Yes, we've always had the Prismo and the UPMC, large format machines, very high accuracy machines. They wanted a smaller footprint machine, same type of accuracy.
Okay, so basically I guess the issue was that the large machines were just way kind of overkill for the size parts that the medical device industry is typically working with.
Too much room in the lab.
Okay, so the same accuracy but a much smaller footprint.
Yes.
Okay, well why don't you tell us a little bit about the MICURA?
Okay, the MICURA is our solution for high precision parts that are small and fragile because we can control the probing force. It uses the VAST XT gold sensor. The stylized systems can be as small as 0.3 millimeter. Probing force can be as low as 50 nanometers, 50 millinewtons, millinewtons,
okay.
Sorry, 0.3 millimeter diameter. In addition, the small footprint is only about 1.2 meters square.
Okay, so this
then the measuring volume is about 500 millimeters cubic.
Okay, so 500 millimeter cube,
yes.
half meter cube measuring volume,
right.
And the whole machine is about 1.5 meters, I think, is that what you said?
About 1.3 meter footprint.
Okay, and how tall?
2.3.
So this basically fits in a really kind of small lab environment, right?
Yes.
Okay,
yeah.
Which is
right
really the goal. Now tell me about the probing force you said is really quite small.
Yes, very low probing force with 50 millinewtons. And that allows us to look at thin wall parts, very fragile parts, delicate parts, without deflecting the part. So we can get good measurements, high accuracy measurements, without deforming the part.
Okay, and obviously for the medical device industry, that's something that's really critical, is they do have a lot of either thin-walled or soft parts that need to be probed. Okay, all right. Well, I think you were going to kind of take us through kind of the ropes here on the MICURA. I think you have an interesting part for us to measure.
Right, we have a knee joint. Here we have a plan ready to go. We're using Calypso software. We'll run the plan. So the machine can it can scan up to 125 millimeters a second at optimum speed, depending on the tolerances. The plan right now is taking about 1,000 points on these profile scans and comparing the information back against the CAD model.
Okay, and I notice as it's scanning, it's doing kind of a snake pattern, a little serpentine pattern on that. What's the reason for that?
We're trying to cover as much area as possible in the shortest amount of time to be able to get enough data density to make that comparison for the profile call out.
Okay, and because this is not a prismatic part, this is a complex shape.
Right.
You really have to take as many points as possible?
Yes, yes. It's there's nothing prismatic about that part. It's all sculpted surfaces.
And tell me a little bit about how many points it's capable of taking at per second, or however you guys measure that?
The VAST XT Gold head can take 200 points per second.
Okay.
At the scanning speed, at maximum speed of 125 millimeters.
And this is still, I'm still interested, this is still at this 50 millinewton?
Still at 50 millinewtons of probing force.
Wow, okay.
Right. So it finished the scan, and now we'll look at the data here, and we'll compare it against the CAD model. And we end up with a color chromatic on the CAD, and we can see that part of it is in, part of it is out of the material, yet it is all in tolerance.
Okay, so this is, obviously we're running what, Calypso software here?
Calypso software.
So you've brought a CAD model into Calypso of this knee joint.
Yes.
And we're simply comparing the points that you've just taken to the CAD.
Yes.
It's given the tolerance there, okay.
And the CAD type of models that we can bring in, people are usually interested in that. There's our list of CAD types that we can bring in. The standard UG, CATIA, Pro-E, SolidWorks type CAD files.
Okay, so pretty much any of the main CAD programs out there, you guys are going to be able to bring in and use for not only your comparison, but also for your parts programming, is that right?
Yes, we program on the CAD model.
Okay, tell us a little bit about, we were talking offline, you were talking about there's a couple different ways to program, whether you're capturing features or capturing, what was it, characteristics?
Characteristics. Yes.
Tell us the difference between the two.
All right, we say that Calypso is characteristic based. So when you look at a print, you see all the characteristics, all the nominals, tolerances, GD&T callouts. We write our plans from those characteristics. Then we associate the features on the CAD model to the characteristic. Okay,
so this is actually more measuring really to what the plans were intended to show to begin with.
Yes.
Okay.
Yes.
All right. So tell me a little bit more about the different probe configurations that are available on the MICURA.
Yes, the VAST XT Gold allows a wide array of styli and styli arrangements. You can have extensions and styli up to 500 millimeters in length. You can build up star probes, and the maximum weight then would be 500 grams of weight.
You said the longest probe could be how long?
500 millimeters.
Isn't that the measuring volume of the how's that work?
Well, you could put one diagonally.
Oh, okay, all right.
Yes.
I was going to say, I don't know how that's going to work. Okay.
That's the capacity of the sensor.
All right, all right. Okay, now I noticed we got dual joysticks on there, and I saw you working with that earlier. Can you tell us a little bit about the positioning of the
yes,
of MICURA?
We use the dual joysticks, one for X, Y, one for Z. Both of them are proportional control.
Okay.
So the further you move it, the faster it'll go, and then coupled with the speed control here also. Okay. So all this is controlled with the joysticks, the two joysticks.
Now, you used the word optimized early on when we were talking about running the parts program, but I don't think you went into that. You guys have something unique that helps optimize a program once the part program has been written by the programmer, right?
Yes, we have what we call the Navigator Option.
Okay.
So by adding the Navigator Option to the MICURA, you get three things. You get the sensor, the VAST XT Gold sensor. You get the controller technology package, and then you also get the software option that allows you then to select, optimize travel, scanning speed, and data density. It'll all do that automatically based on your tolerances.
Okay, so the programmer doesn't need to know anything. This is just happening behind the scenes.
Yes.
And what kind of improvement does it give to the probe path?
Up to 30% increase in throughput in the plans. The runtime would be 30% less.
Okay, so much more faster.
Efficient, more efficient.
There we go, more efficient, okay. By the way, just a reminder, if you have any questions during this show, be sure to send them to techno-live at qualitydigest.com, and we'll be sure to get them here to Terry, and also we'll be showing another product later on, and we want to make sure to get all your questions in. Okay, so tell us, we haven't really touched on the accuracy of the product, so let's deal with that a little bit.
Right, the MPE spec is 0.9 microns plus L over 400.
Okay, so 0.9 microns and then L over 400 for
the volume.
The volume.
Right.
Okay.
The measurement length.
The measurement length, right? Okay. So anyway, that's the equation that, and I'm just not real familiar with all this. That equation gives you the overall accuracy no matter where you're measuring.
Volumetric for probing accuracy.
Gotcha. So this product came out in what? This was what, October?
At Quality, September last year.
September of last year.
Right.
And this was this was kind of a direct request. This product came about directly as a result of input from the medical device manufacturers.
Customers came to us and said, we need a high accuracy, small footprint system with low probing forces for the type of parts that we manufacture.
How's that worked out?
This is our answer. So far it's worked out very well. We've had to double our production capacity in Maple Grove, which is where the machine is manufactured.
Okay. Oh, so this is manufactured in the United States?
Yes.
Okay, so, and where was that?
Maple Grove, Minnesota.
All right. And you know, this is kind of a question I throw out at everybody anytime we're talking about technical equipment. We see the equipment getting more and more accurate over time. They're getting faster, they're getting more accurate. They seem to be getting easier to run, but is that really the case? I mean, you've been, I think you told me earlier, you've been in metrology for 30 years, so you've got a lot of experience behind you. When you see new guys coming in and coming up to speed on a machine like this, do you feel that they're as prepared now as they were 10 years ago to come into this field, which is getting more and more accurate?
Yes to all of that. Most of the students that we see come into the classes have quite a background either in inspection, some form of dimensional metrology. Most of them have had the GD&T type training, so that's not an issue for them. And a lot of the top students come out of the CAD CAM part of the manufacturing, so they can run most of the CAD programs.
You know, we got a question in from a reader. I'm not sure what it means. Maybe you do. It's a question about self-centering.
Okay.
Can you tell me about? He just says, tell me about self-centering.
All right. With the VAST XT Gold head, it's a active head. You can self-center in like a cone or a slot, and it will actually find the center and give you the position automatically. Okay,
and that's part of the MICURA, is that part of Calypso?
It's part of the sensor and Calypso.
Okay. Actually, another question we get quite frequently when we talk about a Calypso is just, in case other people don't know, is the export capabilities of Calypso. If you want to analyze this data, obviously we've talked about looking at it on Calypso itself. Suppose you want to take that data out and do some sort of analysis offline. What kind of capabilities do we have for that?
Right. All the reports can be put out in PDF format. All of the raw data can be put out in any format. Any of the information can go into SPC packages. It can all be sent out over the server to any destination into any format. So if you want to capture it in SPC, if you just want to capture it as text files, you can do that. If you want to put it into Excel, we have an Excel driver that will put it into an Excel format for you.
Okay.
So if you want Minitab, Excel, QDOS, any of those type of packages, we can put the data into it.
Okay. And I want to talk to you a little bit also. One thing I've seen that I'm not familiar with how CMMs work completely, but one thing I have noticed which surprised me is as I see the CMM move, I see the gantry move, I see actually the surface plate kind of rocking as the gantry moves to one side or the other, and that always interested me. How do you take accurate measurements when everything's kind of moving around? What's going on there?
Well, Dirk, the design of the machine, we use the ceramic ways. We have four-sided air bearings that encompass the ways. All the rigidity, stiffness is built into the system. It isn't just the table moving, the whole system moves unitized.
Okay, and that's so that has to do with, I imagine the stiffness is related to the type of material you're using in the gantry and,
right,
and
the
the column
ceramic,
and so forth.
the bearings, everything, the construction.
Okay, and ceramic is very stiff?
Yes,
okay.
Very rigid. Yes.
And, actually, ceramic also, I think, probably plays into temperature compensation, if I remember correctly?
Yeah, the coefficient of expansion.
Okay.
So all that goes into it to where that's how we can state that accuracy at 0.9 microns.
And that's one thing we didn't touch on either was what kind of temperature compensation is in the MICURA?
The temperature range that we run the machine in is 19 to 21 C.
Okay.
At that point, the stated accuracy is there. You can put a temperature sensor on it, which is built in. It's actually on the machine right now. That will, you can attach to the part, and then you can comp for the coefficient of expansion of the part. Optionally, you can add a temperature probe to the machine, pick it up and actually probe the part, not all parts are magnetic, and see what the temperature is, and then on the fly, comp for the temperature expansion.
Okay. Well, Terry, thanks for running us through the MICURA. Is there anything we missed that you wanted to touch on at all? Or?
That seems to cover it.
Is that good? All right. Well, if you have any questions for Terry, remember we'll come back at the end of the show for more questions. So if you have any questions on the MICURA, even though we're leaving it for now, go ahead and send your questions to techno-live@qualitydigest.com, and we will bring Terry back on to answer those later on. So now we're going to move on to another Zeiss product. This is the Surfcom Flex. And here to show us about the Surfcom Flex is Frank Valdez. Valdez, do I have that right? And Frank, you've been with Zeiss for how long?
I've been with Zeiss for a year and almost 2 months.
Okay, so you're the new guy.
I'm the new guy.
All right.
Yep.
So, and you're going to show us the Surfcom Flex.
Yeah, today I'm going to show you guys this new surface texture, surface roughness measuring device from our sister company, Acrotech. They make our SF and G products. And this new device is a surface roughness texture analyzer that's ultra portable. So it can be taken all around the shop floor. And the great thing about it is that it works with a series of tracers. So the tracer is a thing that actually goes and takes your surface roughness measurement. Okay. And the data goes into here and it does all the analysis.
Okay. Now, so what we're really talking about here is the Surfcom Flex is really this box. It's not part. The tracer is a whole nother product, right?
Right.
Because the box is basically what controls the tracer.
Yeah.
Okay. So before this box came along, what were users using?
So along with this tracer, this is our 50A combined with the Surflex. This was part of our Surfcom 130A. And along with that was a grade digital signal processor. The trouble with it was outputting data and sending data to your computer and traceability. And also it was bigger and bulkier and it was not portable. So the great thing about the Surfcom Flex though is that it has a rechargeable battery. So it doesn't need to be plugged in all the time. It has you can carry it around everywhere. Charge time for the battery is 3 hours, give or take 3 hours. And it can run through 600 measurements with that charge. Okay.
So, and how much data can be stored?
The great thing about the Surfcom Flex is that it has a USB output. So now you're only limited to how much your USB stick can hold. Okay. And additionally, internally, you don't need a USB stick. Internally, you can store up to 29 measurement data, and you can have 5 measurement conditions. So the measurement conditions are the settings that are set up for the measurement. That these are your cutoff frequencies, these are your trace lengths, and your measure speeds. Also the standards that they're measured to.
Okay. So if I understand this right, then in the past you had kind of a large box that wasn't portable, and the data output was a little convoluted from what I understand.
Yeah.
Okay, now we've got a very handheld device, battery operated. You can drag it out to the shop floor, take as many measurements as you want, and it's easier to spit out the data for further analysis.
Yeah.
Okay.
At any point you can recall any other data, bring it back in and display it. Or at any point you can bring in old data and change the settings on the way the data was taken and generate new results. Okay. New parameters.
So show us how it works.
Sure. So today I'm going to be measuring on a really small medical part because we are in the medical show. And the interesting about this part, it's a housing for a femoral cutter.
A femoral cutter?
Femoral cutter, yeah.
See, that's the fun thing about being at a medical device show is you get to see all these like things like for cutting you open and
you walk around, you're like, that thing might be in me in a few years from now.
Like we've got a knee over here. Okay.
So the really cool thing about the Surfcom Flex, as soon as you power it up, it takes you to what we call the condition screen. So this is where you set up your cutoff frequencies, your trace lengths, and your trace speed. Okay. So what I'm going to do here is put our probe tip onto the part, and what I want to do is be right in the middle of our measurement range. So that little bar on the side, Dirk, tells you...
So I'm not sure if we're seeing it in the camera here, but we've got a little bar on the on the left-hand side, and you're saying you're just centering this manually so that this little bar is right in the middle, and that's the center of your measurement, right?
Right, exactly. Okay. And that's in Z, that's our Z movement.
Okay.
And the next thing is I have all my conditions set up here with a 0.1 cutoff wavelength, and I'm going to do a 5 times the cutoff wavelength trace at that speed, at 0.024. Next thing I do is big red button that you just hit measure.
It's hard to miss. It says measure.
Hard to miss. Hard to miss also if something that's going to crash, it has a big stop button.
Okay.
So as it's tracing in real time, you'll see a trace of the roughness curve, of the profile curve. And as soon as it's done, it'll take you straight into the results window. And the results window is going to tell you everything that you want to see. These are your RAs, RZs, and whatever other parameters that you told it to do for you.
Okay.
So immediately what we see in the results window is our results for the RA, our PT, RZs, and for whatever standard you're using, you can select the different parameters that you want displayed.
Okay. Now, does this give you, the operator, any kind of feedback in terms of pass, fail, or anything like that?
That's great that you bring that up, because another thing I really like about the Surfcom Flex, exactly for that purpose, is if you need to set up conditions for a parameter and then have it tell you whether it's good or no good, that's possible to do on the Surfcom Flex. And actually, I'll go ahead and show you how we would go about doing that. So I'm simply going to go into my menu and navigate to my output parameters, because that's what I want to work with. And for my output parameters, I say that I want to put some sort of judgment condition. And I'm going to choose the parameter that I want to set that condition to. So for this case, I'll choose an RA. After I've done that, I can set the condition to it. So for this measurement, I believe I was at around 60 micro inches, I believe, that the condition called for.
Okay.
So I set my upper limit to 60 micro inches, go back, simply hit my condition button, takes me right back to my measurement screen, and I get my tracer right back onto the part in the middle of the measuring range, hit measure, and now this time it's going to pop up the same results window, the same RAs and RZs, except for this time what we expect to see is that when it gives us the RA value, right next to it we're going to see the judgment of it. What it's going to tell us whether it's no good or whether it's okay, good to go. Or whether you fall off the part.
Or you fall off the end of the part, right.
So as soon as it's done tracing...
Somehow I got a feeling this one's going to fail.
Oh, this one did fail.
Imagine that.
But a great thing we can do is recall data.
Actually, how do I know? Does it tell me that it failed?
If you were looking at the screen, it just told you cannot calculate from the conditions that you
probably
told
because it went too far out.
Yeah, exactly. Okay. Let me just reset it.
Yeah, let's do that again. And actually, while it's running this time, tell us a little bit about the accuracy.
Oh, it's great that you ask about the accuracy of the machine, because when we talk surface roughness, we're not really talking about accuracy. When we talk about accuracy and surface roughness, we're talking about the tracer, the driver. So we want that tracer to be straight to some degree, right?
Okay.
So the straightness of this specific driver is 0.3 micron in that 50 millimeter measuring range. Now, when we talk,
let me interrupt. So I didn't quite. When you say accuracy, it's not the accuracy of the surface measure. Is it actually the accuracy of the trace that you're
of how straight it's moving.
The line is. What's that all about?
Well, you don't want it going back and forth, because then you might be getting noise that's unwanted.
Okay.
You want a straight trace. So what we're really looking for in surface roughness measurement is resolution.
Okay.
So the resolution we get with this specific tracer, depending on what measuring range you're working with, can be up to 1.6 Armstrongs.
Oh, okay.
So what's that sensing? It's the Z movement. How much movement is it sensing? So that's what's telling us the resolution, and that's going to give us our truest surface roughness measurements.
Okay. And so we ran this again. Now, obviously, okay. So now I'm seeing that this passed. Then
exactly.
The okay was the pass. Now, suppose I'm assuming that this is collecting raw data, and what we're getting here is raw data. So can you take that raw data and do something else with it?
Yeah, another great feature about the Surfcom Flex is that at any time you can recalculate data by resetting different settings, different parameter settings. If you input the wrong cutoff frequency, for example, you can go back, change it, and recalculate that data. So actually, I'll go ahead and do that right now. I'll go back into my menu and go into some of my settings here that I want to change. For example, let's say I wanted to change my cutoff value from 0.1 to 0.003 because that was the correct value to use. So it's going to take the data that's currently loaded, which is the one that we just measured right now.
Right.
And as soon as I hit enter, it's going to execute a recalculation of our measured data. And so as soon as I change it, you see a different value now for the RA.
Okay. So basically we didn't run the test again. This is simply taking the existing data and just recrunching it.
Exactly.
Okay.
Exactly.
Now
Right.
what about, you mentioned earlier that this will measure to different types of standards. Can you tell me a little bit more about that?
Yeah, definitely. So depending on what your print calls out for, you can have the Surfcom Flex measure to those standards. And if we take a look at the screen here, we see all the different standards that are available on the Surfcom Flex. Right now I was using the ISO 97. Let's say I wanted to measure per the ASME standard. I can change it to that standard and then recalculate my data.
And so it's going to take the same data, but it's just using a different standard
Exactly.
to calculate. I guess the standards are just the different calculations. Is
Yeah,
that right?
it could be a different algorithm, how RA is interpreted or RZ.
Okay. So the usefulness of that, I would imagine, is if you have a part that's going maybe overseas and that same part maybe is being used domestically, the client overseas wants their reports in ISO standard, and here they want them ASME standard.
Exactly.
Then you would just take the same data, run it twice.
Exactly.
2 different reports.
Right.
Okay, and you can output those reports.
And addition to being able to output them digitally, the Surfcom Flex comes with a printer. So at any point in time, if you need hard copy of your results, you can get the surface roughness parameters, and you can get all your profile traces and your surface roughness trace. So you can attach it to your Calypso report, perhaps.
Okay. Actually, we just had a question come in that's for Terry, but actually I'm going to ask it about you too because I think it applies.
Okay.
It's a question about the temperature compensation of the MICURA, and we will get back to that question in a little bit. You say this is a shop floor machine, so this is basically a controller, but when we're talking about the tracers themselves, what kind of environment do they operate in?
Well, they are designed for a shop floor environment, so they are designed to take the harsher, higher temperature ones.
Okay, and still maintain their accuracy. And I think you also mentioned these are all traceable, right? The calibrations are traceable on the tracers themselves?
Yeah.
Okay. I'm sorry, we got off track here because I was looking at somebody's question there. All right.
So actually I wanted to,
that little
blip we had on me doing another measurement.
Okay.
So what's a really cool tool when you're using this tracer is that the Surfcom Flex has a return button. So when you're using this specific Surfcom tracer, all you have to do is take the probe off the part, I hit the return button, and it takes me back to the exact same measurement start position as the last measurement run.
Okay.
So I could have just simply used that button.
And just rerun the test.
Literally rerun the exact same line that I had.
Okay.
That I had
now
traced.
you mentioned with this particular tracer, so does this new controller work with all the old tracers? So like if you have a bunch of your older tracers laying around with the old controller, if you just want to replace the controller, you can do that?
Right, so this works with a 35, a 40, 45, and the 50. So it's with 4 different tracers. So why with 4? Because depending on your workpiece, you might need a different type of tracer. This one has a 50 millimeter range in X. The other ones have a 12.5 and a 4 that moves in Y.
Okay. And how easy it is to train somebody to use this?
Well, what I really liked about it was that I'd never seen the device, and it was shipped to me, and I opened it. Straight from opening it, I was able to use it in a few hours.
Okay.
And so to train someone to just hit go, so easy.
And I think we mentioned earlier that you can store on here actual test. What would you call them? Test parameters?
Yeah,
test routines?
measurement conditions.
Measurement conditions.
So,
okay.
For example, if you have one section of the shop floor that you have an expected RA of 64, you know you need this cutoff. Over there, you need another cutoff. So you just set up different measurement conditions, different speeds for each condition, and you just recall that condition and hit measure, and you're good.
And from what I remember, the operator could just call that up. So you could have several of these conditions stored on there. The operator, all he or she needs to know is
exactly
just which Which conditions to pull up.
And again, what comes in really, really handy is that USB output. Okay. So at any point, like I said, we have 5 storage places for measurement conditions, and we have 29 storage places for measurement data. Okay. At any point you stick your USB stick in there, in a batch, you can take all of them onto your USB.
Okay. Now, we saw one kind of plot on here. Can you do other types of plots?
Yeah, definitely. So by the 3 most frequently used buttons, which are measure or graph and condition, I just click onto my graph button and it takes me into the graph of the trace that we took. Okay. So as soon as I press it again, it toggles back to my roughness parameters. So if I can actually toggle through this graph and show you different types of graphs. So what I'm going to do is show you the different types of curves it can display. So this one's displaying an ISO curve. This one's displaying a BAC, other statistical curves that are desirable with surface roughness. That's for profile, that's for roughness. This is an ADF curve for profile, and here's an ADF curve for roughness. And all these curves, again, you can select to print them. Okay. At any time.
And real quick, and we do have a question that just came in, but real quickly, you mentioned one of the strengths of this was not only its portability, but the ease of export. So tell us, the export is simply just the ability to connect a USB to it into a computer and suck the data out of it. Is that the?
Well, not just that. You can actually connect this device to the software that Acrotech makes, which is ActiPro. Okay. And it's a surface roughness and contour analyzer software. So via mini USB, you can hook up to your PC, given you have the correct drivers, which they include, and do further analysis on that software.
Okay. Now, we did have a question come in. What limitations are there to using the Surfcom Flex out in the field? We need to take these types of measurements in a dusty, dirty environment.
Well, so long as you're storing your Surfcom Flex in a clean place, it's just a matter of taking it out to the shop and just measuring. So, I mean, the thing is small enough to where you can protect it easily with a shroud.
Sure.
Yeah.
Okay. Okay. Well, Frank,
Dirk,
did we touch on everything you wanted to hit on this
Definitely,
product?
definitely.
Okay,
yes.
Great. So I'd like to bring Terry back up. Terry. There we go. We had a couple questions come in, of course. Well, once you finish, then all the questions came in. That's usually what happens to us. So let me run back to a couple of these. Some of these you may have already touched on, but I think this person may have come in a little late. This one's from Alan. Is the stated MPE for the machine? Is the stated MPE for the machine only, or does it include the probe accuracy?
It is probing accuracy. MPE is 0.9
with the vast gold. I think that's
L over 400.
So I think I think that was his question.
Accuracy.
Is the probing accuracy is measured with the vast gold?
Yeah, vast gold.
Okay, Alan. I hope that answers your question. Okay. This is different. I've never heard of this, but well, let's give it a try. Ask Terry about how flexible the CMM is in regards to the pressure of the probe. We have a need to measure or exert various amounts of pressure on different parts. I think he's saying measure at different probe pressures. Can you actually, is that a capability? I've never heard of that, but is that a capability?
Yes, on a feature-by-feature basis, you can change the probing pressure.
Really? Okay.
Yes.
I just figured it was just how, okay, so you can actually adjust how much pressure you're exerting on a particular feature. Obviously, probably not as you're scanning, though.
Well, once you scan at one pressure, it stays at that pressure during that scan path. Okay. Not variable pressure within the scan path.
Exactly. But so within the probing program, you could specify what the pressure was for a particular
scan,
path.
And then another path, a different pressure, another path, a different pressure.
Okay. Well, I learn something new every time I do one of these. Okay.
That's really one of the great things about Calypso, Dirk, of how much editing you're able to do, how much control you have over every move and every probing.
Okay. And that's something that's, so that is, as Frank alluded to, that's something that's actually done in the Calypso then, during the software, during the programming?
As you program it, you can change it, and like Frank said, even after you program it, you can change it.
Okay. All right, thank you. Okay, now this was a question that came in for the MICURA, but I actually asked it of Frank. Terry talked about the temperature compensation of the MICURA. but what is the range in which the unit can operate even without compensation?
19 to 21C.
19 to 21C without compensation.
Without compensation.
And with compensation, what was the range again?
17 to 35. Ambient, outside, but for the accuracy, it has to be within 19 to 21.
Okay, gotcha. And so it's up to the user whether they use the temperature comp or not. Are there certain, I mean, just for my own information, are there certain times when you just don't want to use temperature compensation? I mean, is that just people just don't trust it? Maybe they don't want to use it?
Most of the labs, they don't use it because they have the ambient set at 20 degrees C.
Okay, so it's just an extra thing they
add
throw in
and
they don't want to.
If they have a temperature gradient within the lab, then they'll add that in. Okay. Also, they'll use the temperature comp if they bring in parts that have not temperature soaked yet.
Ah, good point. Okay. So this could be one of those cases where if you needed to measure a part right away, and you didn't have time to soak it, you could actually measure it and know that the temperature of the part's been compensated for. Okay. All right. Let's see. Just checking to see if we had any other questions from our viewers out there. Remember, you have just a couple minutes left, so if you want to send questions to techno-live@qualitydigest.com on the MICURA or the Surfcom, we will get them here, just if you do it quickly, because we're running out of time here. Was there anything either one of you wanted to touch on in terms of either of your products that, we've got a couple minutes here and I want to let people have some chance to send some questions.
Yeah, sure. I'd like to add on that the Surfcom Flex offers a really cool tool, additionally for the operator. So you'll have instances where the operator is not very familiar with surface texture, surface roughness measurements, and maybe they don't have someone to guide them through it. So with what we get with the Surfcom Flex is this function that's called the AI function. And what you do is you put in the expected roughness, your RA that's on the print, and this function helps the operator determine the ideal trace length and the ideal cutoff frequency.
Okay, so even if they're not familiar with maybe how to set up a particular test, this is actually going to pretty much do it for them based on their input parameters.
Yeah, it finds the optimum cutoff frequencies and trace lengths.
Okay. All right. Okay, well, we haven't gotten any more questions, so I think we've about tapped you viewers out. We hope we answered all your questions. If you have any more questions on the MICURA or the Surfcom, still send them to that address below, techno-live@qualitydigest.com. We'll keep receiving the questions. We'll be sure to forward those questions to these guys later, so you will get an answer from them even once the show is over, so don't worry about that. And once again, I'd like to thank Terry Rosine.
Thank you, Dirk.
And
thanks,
Frank
Dirk.
Valdez, applications engineers from Carl Zeiss Industrial Metrology. We've seen the MICURA CMM, the Surfcom Flex. Like I said, if you got any questions, go ahead and send them to us. But we're done for today. Do want to remind you that every Friday morning we have a live program called Quality Digest Live at 11 a.m. Pacific time, where we cover the top news stories from the world of quality. We cover metrology, quality management, anything really that interests us that week, we get to show to you on Friday morning at 11 o'clock from 11 to 11:30. Be sure to look on our newsletter when you get it. There's always a link down there at the bottom. So once again, thanks to Carl Zeiss Industrial Metrology for inviting us. Thank all of you for joining us on TechnorazziLIVE, and we'll see you on the next one. So long.